Math used in saxophone. The saxophone, a versatile wind instrument, is a product of mathematical precision in acoustics, design, and frequency control. Mathematics plays a vital role in ensuring the saxophone produces rich and harmonious tones. Let's explore the role of math in the saxophone. Saxophone uses math in sound, frequency, and pitch. The pitch of a saxophone note is determined by the length of the air column inside the instrument. The mathematical relationship between frequency and wavelength helps in designing the instrument to produce accurate musical notes. Key placement and spacing. The arrangement of keys follows a logarithmic pattern to ensure that each press produces the correct note, maintaining consistency in pitch intervals. Resonance and harmonics. The saxophone utilizes mathematical principles of resonance, where overtones and harmonics are formed based on frequency ratios, creating a rich and full sound. Wave motion and airflow. The behavior of sound waves within the saxophone follows mathematical equations related to standing waves and airflow dynamics, affecting tone quality. Musical scales and intervals. The division of an octave into 12 semitones follows a geometric progression, with each note being a fixed ratio, 1.059, of the previous note's frequency. Mathematical principles applied. Frequency and wavelength equations ensure the correct tuning of the instrument. Logarithmic and geometric patterns determine key spacing and musical scales. Harmonic series and standing waves contribute to tone production and sound quality. From pitch control to harmonic resonance, mathematics is deeply embedded in the saxophone, making it an instrument of both art and precision.